In this video, let us solve few more trigonometric identities. So please pause the video and note down the questions. Please try it out yourself and you can come back to the video and check for the solutions just to compare what the approach is. So please pause the video now. Now let's solve the first problem. Here we have to prove that sine theta minus 2 times sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So if you notice here, we have to arrive at tan theta. That means we have to apply trigonometric ratio identities here related to sine and cos, which will cancel out eventually. So let's try to solve this problem now. Let's take sine theta as common in the numerator. This will be sine theta and 1 minus 2 times sine square theta divided by, in the denominator we will have cos theta and 2 times cos square theta minus 1. Now cos square theta plus sine square theta is equal to 1. So cos square theta can be replaced as 1 minus sine square theta. Let's replace that here. So this will be sine theta times 1 minus 2 sine square theta divided by cos theta times 2 times 1 minus sine square theta minus 1. Now let's simplify the denominator. We will have, so sine theta by cos theta, now let's write it as tan theta. And this will be 1 minus 2 times sine square theta divided by 2 minus 2 sine square theta minus 1. So if we observe here, 2 minus 1 is 1, and this denominator again will be equal to 1 minus 2 sine square theta. So we can cancel this out and we will remain with only one function, which is tan theta. So this is how you can approach the first problem. Now let's solve the second problem. Here we have to prove that sin a plus cos a the whole square plus cos a plus secant a the whole square is equal to 7 plus tan square a plus cot square a. So on the right hand side, we clearly see that we only have tan square a and cot square a. That means we are going to use trigonometric identities again, which are related to tan and cot. And which are those? 1 plus tan square a is equal to secant square a, and 1 plus cot square a is equal to cosecant square a. And there is one more, which is sine square a plus cos square a is equal to 1. So we are definitely going to use all these three. Let's see how we can solve it. So let's apply a plus b the whole square to both these parts of the question. So this will be sine square a plus cosecant square a plus 2 times sin a cosecant a plus, let's apply a plus b the whole square to the next part now. This will be cos square a plus secant square a plus 2 cos a secant a. Now let's start grouping the things so that we can cancel few things or substitute it with trigonometric identities. So we have sine square a plus cos square a. Let's group that together. Sine square a plus cos square a. Then we can group cos square a and secant square a. I mean cosecant square a plus secant square a. Sorry about that. Then we can change cosecant a to 1 by sin a. So this will be 2 times sin a times 1 by sin a plus Now we'll solve for this one. This will be 2 times cos A times 1 by cos A. So we can cancel the cos and the sine values. Now let's apply the trigonometric identities here. So what would the first part be? This would be 1 plus, now cosecant A is nothing but 1 plus cot square A, then plus secant square A is nothing but 1 plus tan square A, then this would be plus 2 plus 2. Now let's add all this. So we have 1, 2, 3 and then 4. So this would be 7 plus cot square A plus tan square A. So this is what we will get once we solve this equation. So please take a note of how trigonometric identities can be applied, and also the algebraic equations like a plus b the whole square or a plus b times a minus b, which is a square minus b square. So we can apply all these equations to arrive at the solution. Let us solve the third problem. Here we have to prove that cosecant A minus sin A times secant A minus cos A is equal to 1 by tan A plus cot A. So to solve this, let us change cosecant and secant to 1 by sin and 1 by cos respectively. So this will be 1 by sin A minus sin A times 1 by cos A minus cos A. So if we solve for the common denominator, we would get 1 minus sin square A divided by sin A times 1 minus cos square A by cos A. Now if we apply the trigonometric identity sin square A plus cos square A is equal to 1, we can replace 1 minus sin square A as cos square A, and in the next part we can replace 1 minus cos square A with sin square A. Now what we would get is sin A cos A would be the value here. But if you notice, in the right hand side we need 1 by tan A plus cot A. So we need something in the denominator. So this is one interesting problem we can solve. So we can write sin A times cos A as sin A times cos A divided by 1, and this one can be written as sin square A plus cos square A. So this will be cos A sin A divided by sin square A plus cos square A. And we have just written 1 as sin square A plus cos square A. Now divide the numerator and denominator with sin A and cos A. So we would get 1 divided by sin square A plus cos square A divided by sin A cos A. Now just divide each value with the denominator. We would get 1 by sin square A divided by sin A cos A plus cos square A divided by sin A cos A. Now we can cancel one of the sin values, and in the other part we can cancel one of the cos values. So sin by cos would be tan. So we would get 1 divided by tan A, and in the second part it would be cos by sin, and it would be cot. So this is how we can solve the equations by replacing the denominator with, if there is 1 in the denominator, if it is required, we can replace that 1 with sin square A plus cos square A. So this is a unique problem. Please try to solve more problems like this. it will be helpful for you to solve the complex ones. Let us solve the fourth problem. Here we have to prove two parts. We have to prove that 1 plus tan square a divided by 1 plus cot square a is equal to tan square a. Also, the second part, which is 1 minus tan a by 1 minus cot a, the whole square, is also equal to tan square a. So let's pick the first part, which is 1 plus tan square a divided by 1 plus cot square a. So if we apply the trigonometric identities, the numerator would be secant square a and the denominator would be cosecant square a. Now secant square a is 1 by cos square a and cosecant square a is 1 by sin square a. So if we solve this, we would get sin square a divided by cos square a, which is tan square a. Now let's solve the second part, which is 1 minus tan a divided by 1 minus cot a, the whole square. So let's apply the inverse function for cot a. So this would be 1 minus tan a divided by 1 minus 1 by tan a. We just replaced cot a by 1 by tan a. Now let's solve the denominator. Here we would get 1 minus tan a divided by tan a minus 1 divided by tan a, the whole square. Now we can cancel the numerator and the denominator, but this would retain the minus 1 value. So we will get the value as 1 by minus 1 by tan a, the whole square. So when we square a negative value, we would always get a positive one. So this will end up with tan square a. So this is how we can prove both the parts of the equation to be equal to tan square a. If you like the video, please subscribe the channel and share it with your friends. Thank you for watching. I'll see you in the next video.